Hello friends, welcome to the channel Physics by IITians.
Hello friends, this is a very important lecture of vectors and we have already completed 2 lectures of vectors. So before coming to the lecture, I would request you please watch these 2 vector lectures where we have discussed about the divergence, curl of a vector and many more things about vectors, the basics of vectors. So in this video, we shall discuss about the integration or in vector calculus. Okay, we shall discuss the line integral, the surface integral, the volume integral, and we will solve previous year questions with some easy tricks. So I request you to watch this video carefully. So friends, you all know that what is vector. Okay, you all know what is the divergence of vector, what is the curl of vector, how do we represent r, that is in the polar coordinate, in the Cartesian coordinate. I assume you know all the basics of vector. So the line integration of vector is known as or is denoted by integration over, that is represented as C f dot dr, or it can be represented as integration over C f dot dl. Okay. So what is the meaning of the line integration? So the integration of a vector of a curve is known as the line integral. And suppose f, that is the function of x, y, z, is a vector function and a curve that is AB. Okay, so the vector function is f and the curve is AB. So the line integral of a vector function along the curve is defined as integral of the component of f along the tangent to the curve AB. So first you have to find out the integral, the function that is f, the vector function, what will be the component of f along the tangent of this curve, and that is the line integral, and that is represented by integration over C f dot dr. Now in physics, how do you understand that? What is the physical meaning of the line integration? Actually, if f, suppose the f represents a variable like force, like electrostatic force. Okay, so on a particle along, or just like a mechanical force, if f represents a variable force that is acting on a particle along the arc AB, then the total work done is integration over A to B f dot dr, that is the force that is acting on the particle on this, and the work done is integration over f dot dr. The integral will be from A. Now, if we represent the velocity of a liquid, okay, so then closed integral over C v dot dr is called the circulation of V around the closed curve. So suppose you have a liquid and your V is the representation of the liquid velocity. Okay, so velocity vector of the liquid, and closed integral over or closed contour of V dot dr represents the circulation of velocity vector around the closed curve. So what is the meaning of this closed integral? The path integration is the closed curve and this notation is the closed integral. Okay, so the property is, that is, suppose the work done by a conservative field, then what will be the line integral? The line integral will be path independent. So this is the property of the conservative field. Now the work done by a conservative field in moving a particle around a closed path, that is C, it can be written as closed integral over C to 0. So similarly in electrostatics, if you find out that you are taking a charge and you can move the charge from a particular point to particular point B, work done by for moving the charge particle from A to B is path independent. Okay, and for the path it is. So suppose we are taking an example, that is closed integral over C f dot dr. We have to evaluate vector, that is f equals to 5xy minus 6x square into I cap plus 2x minus 4y into j cap along the curve in the xy plane given by y equals to x cube from the point 11 to point 28. So the x point is changing from 1 to 2 and the y point is changing from 1 to 8, and you have to find out the path integral. So r here is x I cap plus q square. Yes. So here 5x square, 5xy minus 6x square. Let me first, here I am showing you so that you understand it very here. Look here. So f dot dr we have to find out. We have first find out dr. So here that is f dot dr. So we have to find out dr. So for dr, we have to know first out the r. What is r? R is x I cap plus y j cap. Here y equals to x. Okay. So in place of y, you can write it as x cube. So I cap plus y j cap. Okay. So here, let me zoom it so that you understand it. So here dx I cap plus 3x square dx j cap, that is dr. Okay, so f dot dr you can write f is given as 5x to the power 4 minus 6x square I cap plus 2x cube minus 4x j cap dx I cap plus 3x square dx, that is dr. So you just put the dot product. Look here, after performing the dot product, integration is totally scalar because f dot dr is a scalar quantity. So you don't have to be worried about the integration, just like simple integration rule. You have to do the integration, the result will be 35. Now this is a traditional method. Okay, you can do it with applying Stokes and I will tell you the short trick. So this is the traditional method. So suppose here in the last question we have used coordinate for x. Okay, in some problems you may find that the Cartesian coordinate should be converted to the polar coordinate, and the is B. Suppose we are taking this example. If a force field, that is A, which is y plus 2x I cap plus 3x plus j cap, is applied to a particle, okay? And then the work done by the force field in traversing the particle around the circle C in xy plane with center at the origin and radius 2 unit is equals to 2 pi, 4 pi, 8 pi or 16 pi. So here you are given the force field and the question is asking that what will be the work done by this force field for traversing a particle around a circle in xy plane. Okay, so what you have to find out, that is closed integral over C A dot dr. Whenever they are telling you you have to find out the work done, then you have to understand that I have to find out closed integral over A dot dr. Okay, so because this is a force field is a vector field here. So A, in place of A you put y plus 2x and this I cap plus 3x plus 2y j cap. Now dr, in place of dr you can write as dx I cap plus dy j cap. So a now dr will give you y plus 2x dx plus 3x plus 2y dy. Now put this as x equals to r cos theta and y equals to r sin theta, where r is given as 2 as r is the radius. Okay, r. Okay, so here just put the value in place of y and x. That is y will be 2 sin theta, 2 into x will be 2 into 2 cos theta, that will give you 4 cos theta, and dx will give you minus 2 sin theta this theta, because 2 cos theta you differentiate, okay, and dy will do cos theta d theta because you differentiate dy with to theta also. So solve this integration and the integral over 0 to 2 pi, because a circle, if you are traversing around the circle after a complete cycle, you will be going from 0 to 2 pi. So that will give you the contour or closed contour for this circular path. Okay, so the result will give you 8. Suppose I am taking another example. Suppose I am taking this one example, that is f given as y I cap minus x j cap, and evaluate the c, that is the integral line integral over f dot 0 to 1 along the following. So the first you have to find out f dot dr from 0 to 1 for the parabola y equals to x square. So what you have to do here? First find out f dot dr equals to f is y I cap minus x j cap, okay, and dr is dx I cap plus dy j cap. So f dot dr will become y I cap plus x j cap dot dx I cap plus dy j cap. So it will give you a scalar function that is y dx minus x dy. Oh, sorry, here it will be plus. So here, here it is minus actually. The sign is a mistake. Here, look here, the function y I cap minus x j cap. So it will be y I cap minus x j cap. So the answer will be y dx minus x dy. Okay. The first you have to find out the path integral along the parabola y equals to x square. So the C is the arc of the parabola, that is y equals to x square, that is from 0 to 1 1. So here dy you can write as dy equals to 2x into dx, and x is varying from 0 to 1. So what you have to do here, in place of y, convert it to x, and in place of dy, convert it to dx. So just put the value, that is y into dx, it will become x square into dx, because in place of y you are writing x square, and x into dy, so x will be x, and in place of dy you will get x into dx. So the integration will be integration of 0 to 1 x square dx minus x into 2x dx, that is integration over 0 to 1, because x is changing from 0 to 1. That's why you are taking integration over 0 to 1 into minus x square dx, that will give you minus 1 by 3. Okay. Suppose I am taking this is another path, that is the suppose you are taking 0 0 to 1 1 contour first from the straight line from 0 0 to 1 0 and then to 1 1. So first this one 0 to O to B, and then you go B to A. There are different paths for going from O to A. You can choose the first path, you can choose the curve path, or you can choose this path, that is first from O to B, then to B to A. And then you are finding out what will be the line integral. So for the B case, that is the straight line, first you go from 0 0 to 1 0 to 1 1. So here along the OB, that is 0 0 to 1 0, the y change is 0, because you are going along the x. So along x there is no change in y. So y will be 0 also, dy will be 0, only x varies from 0 to 1. And along B to A, that is 1 0 to 1 1, the change in x is 0, because here also at the point B the x is 1, and at the point A the x is also 1. The value of x is also 1. So x equals to 1 means no change in dx. So dx equals to 0. So y varies from only 0 to 1. So integration over f dot dr can be written as 0 0 into dx, because the value is it is y into I cap dx minus here this integration y dx minus x dy. So y is 0, in place of y 0, that is for 0 to 1 to dx, and dy is 0 here. 0 to 1, that is the next path, that the dx will be 0 for that, only dy will be surviving. So here dy, and the change is the value of x is 1. So this is minus 1 into dy. So it will give you the value 1. So this you are dividing the two, that is one which is changing from which is the changing in x, and another is changing in y. The changing in x there is no dy value, and for changing in y there is no dx value. Okay. Suppose the third part, that is the straight joining 0 0 to 1 1, that is this one, the third part. This is from 0 0 to 1 1. So what will be this? Then you find out the equation of OA, that is y minus 0 equals to 1 minus 0 by 1 minus 0 into x minus 0. So you are finding that y equals to x. So dy equals to dx, and x 0 to 1. Okay. So you can write it, the integration over f dot dr equals to integration over 0 to 1 x dx minus x dx, because here y you write it as a, and dy you write it as dx. So it will give you 0 path. So here friends, this is not a conservative force field. Okay, because look here, different paths, 3 different results of work done. So work done is path dependent. So it is not representing conservative field. So whenever you are finding out the conservative field, you take the line integral and closed line integral. Then if it is 0, then it will represent a conservative field. So the next we will discuss the surface integration. Just like the line integral, surface integral is the same. Earlier we did it with the integral over the line. Here we will do is integration over the surface. What will be the direction of the surface? Because the volume, because it is a vector, okay? So the vector, you have to understand that we should consider the direction also. So direction of a surface is perpendicular to the plane of the surface. If it is the surface ds is the component that is xy plane, surface segment I am telling you, that is along xy, that is within xy plane, then the direction of the surface will be along z plane. That is along n cap will be along z cap. Okay. If the surface within yz plane, the direction of the surface will be along x cap. If the surface is along xz plane or zx plane, the direction of the surface will be along y cap. Okay. So the perpendicular direction it is represented. The surface integral is represented as integration over a dot over the surface. That is here. The surface integral over a dot n cap to ds, where ds is the surface element and n cap is the direction of that surface element ds. Okay. So in physics, what is the meaning of the surface integral? Surface integral represents the flux of that vector quantity. Suppose a represents the velocity of a liquid. So what will be the flux of the velocity of that liquid? That is the outward flux. We are telling in terms of the electric flux also we know. Okay, the rate of change of the amount of the. How do I say this? This I am thinking that what should I tell you that what is the flux? Outflow, net outflow. Okay, so net outflow of the field, that is a representation. So it is denoted by the surface integral of that surface of that quantity. And also here for the, if this is a solenoid vector function, that is outcome of the flux, then what will happen? If this is a solenoid field, then the flux will be 0. That is surface integral over a dot ds or a dot n ds is 0. That is, suppose we are taking the conservation of charges. What does it mean? That the conservation of charges or total flux of the charge will be 0. Because how much flux charge is incoming, that much charge is outgoing. There is no creation or generation of the charges within certain volume. Okay, so these are the meaning of this mathematics. Now suppose I am not going to tell you what are the process to find out the surface integral, because I have some good method for finding out the surface integral, but please I suggest you to know how to calculate surface integral for the traditional, okay, for any vector field. So, and this is one is the volume integration of a vector, that will be represented as integration over v a dot dv. Okay, so dv is the dx into dy into dz, that is the infinitesimal elementary volume or super small volume for that particular segment. Okay, for that particular object or segment which we are considering. So here we have, what is most important here, the two theorem, that is the divergence theorem and the Stokes theorem. So divergence theorem, you don't have to find out the volume integral. What you have, you don't have, you have to you can convert the surface integral into a volume integral, and the Stokes theorem also you can confine or you can convert a surface integral to a line integral. Okay, how? First you know what is the divergence theorem. So the theorem, but remember this theorem is applicable only for the closed surface, and this theorem converts the surface integral into volume integral and vice versa. And surface is a closed surface. And what is the divergence theorem? That is, if V is the volume bounded by a closed surface S and A is a vector function of position with continuous derivatives, then volume integral over V del dot A dV, that is equals to closed surface integral over S A dot ds or A dot n cap ds. Okay, so closed surface integral, you should understand it. This is the not open surface, but the volume is the open. There is no closed volume, but the surface is closed. And what is the Stokes theorem? theorem is applicable only for open surfaces, and this theorem converts surface integral into line integral and vice versa. So if S is an open two-sided surface bounded by a closed non-intersecting curve C, and A is a vector function of position with continuous derivatives, then closed integral over A dot dr, that is surface integral over curl of A dot ds or dot. Okay, so here this is the divergence. Here the surface integral is closed, and for the Stokes theorem the line integral is closed. Okay, and I think that how to find out the divergence of A, how to find out the curl of A. If you don't know how to find out, go to the previous lecture. I will also in the description box. Okay, we are discussing previous year question. Suppose I am taking an example first. Okay, so this is a CSIR December 2013 example. So here the question is A equals to yz I cap plus zx j cap plus xy k cap, and then you have to find out the integral, that is closed integral of dot dl, where C is the along the perimeter of a rectangular area bounded by x equals to 0, x equals to a, and y equals to 0, y equals to b is how much. So friends, don't do here the traditional method, okay? Because whenever there is a closed integral over C, you can apply the Stokes. Yes. So you all are intelligent, so you understand that we can apply Stokes theorem. If we find out the curl of A, then we don't need to find integral over line integral of A dot dl. So calculate curl of A, and after calculating you get curl of A as 0. So this force is a conservative force. So curl of A is 0 means closed integral over C A dot dl is 0. So answer is option D. Okay. So next question, it is CSIR June 2014 question, that if A vector, that is yz I cap plus z x j cap plus x y k cap, and is the circle of unit radius in the plane defined by z equals to 1 with the center on the z axis, the value of closed integral over C A is how much? Similarly, just do with the Stokes theorem, because they are asking you the closed integral over A dot dl. So calculate curl of A for A equals to yz I cap plus xz k cap j cap plus xy k cap. You get curl of A equals to 0. So closed integral over C A dot dl equals to 0. So how simple is that? Just remember the trick that whenever you are asking to find out the curl of closed integral of something, just you do the curl of that vector field. Okay, and or just do with the Stokes theorem. That's all. So suppose I am taking another question. The work done by a force in moving particle M from any point xy to a neighboring point x plus dx, y plus dy is given by dw equals to 2xy dx plus x square dy. The work done for a complete cycle around the unit circle is how much? So here the work done for a complete cycle around a unit cycle, that is integration over dw, that is closed integral over 2xy dx plus x square dy, or you can write it as 2xy into I cap plus x square j cap dot dr, or you can convert it that curl of 2xy I cap plus x square j cap dot ds and curl of 2xy I cap plus x square j cap is 0. So it will give you the this just evaluate this integration dot ds, it will give you result. So here, what you have done here, you just write in terms of f dot dr, closed integral of f dot dr, and you write it that curl of, okay, and you calculate the answer. We are going with another JAM question. This is previous year JAM question from the JAM question paper. That is the line integration over a to b f dot dl, where f is x by root over x square plus y square I cap or x cap plus y by root over x square plus y square j cap along the semicircular path as shown in the figure. So here the path is given from A to B, and the function f has been also given, and you are instructed to find out integration over A to B f dot dl. So what you have to understand here, this is the line segment, that is the curve path, that is DL, okay. So actually you are segmenting this curve path to smaller segments DL, and you are adding all the segments from A to B. That's why this is giving you the of A to B F dot DL. So this is the infinitesimal summation of F dot DL. Okay. So F dot DL, so what you have to write here, the A point is minus 1 comma 0 and B point is 1 comma 0. So you take integration from minus 1 comma 0 to 1 0, and you value of F dot DL as x dx plus y dy divided by root x square plus y square, because F is uh, and y is f of a, and dl will be dx into so dx into x cap plus dy into, okay. So you find out, you convert it to the polar coordinate. For that, simplification of your calculation. So polar coordinate, you can write x equals to r cos theta. Here it is of 1, okay, r equals to 1. So x equals to cos theta, so dx equals to minus sin theta d theta, and y equals to sin theta, so dy equals to cos theta d theta. So you write minus 1, 0 to this is minus pi, okay, and you are going from minus pi to 0, because you are from, if this is the 0 and the rotation is like the rotation from 0 to 2 pi. So here the contour rotation from minus pi to 0. So you take the integration as minus pi to 0. So here the after simplification you get the result, okay. So friends, the next question is, it is another question, and this is from GATE paper. A vector field is given by f, so this is a function of r, okay, is equals to alpha x j cap minus y I cap for x square plus y square less than equals to r naught square, that is region 1. This is the dot within the dot, and alpha r naught square x j cap plus y I cap divided by x square plus y square for x square plus y square greater than r naught square. So this is the region 2. Okay. So here find the curl of the field for both the regions and find the line integral, that is f dot dl, along the closed semicircle path of radius 2r0 as shown below. So the vector field is here. Definition I have already told you that for the region 1 you calculate curl of A for, okay, and for the third question is the line integral of f dot dr. So you can convert to the surface integral, that is curl of f dot n cap ds. So you divide it into two regions, one for the curl first region plus curl of f n dot ds or dot n cap ds for the second region. So first region it will k cap, and for the second region curl of f is 0. So here the first region put the value to alpha k cap dot n cap ds. So here n cap is along k cap, okay. Here you put the value and you get as, because this is the plane of xy. So xy plane, the surface is along z cap. So z cap is k cap. So 2 alpha k cap dot k cap ds, that is the answer is alpha pi r naught square. Okay. So integration over ds is pi r naught square by 2. So friends, you have to remember it that whenever you are finding out the surface integral over xy plane, what is the direction of the surface? The direction of surface, that is n cap, is along the k cap direction. The next question, vector quantity. So here I am showing you a vector represent the line integral of a scalar field. Okay, this is the visual representation for the line integral of a scalar field. Look here. So here A to B, and this is giving you the line integral of the scalar field. And now I am showing you the line integral of a vector field. look here how the line integral of a vector field is actually visually can be represented. This is the line integral of a vector field. Okay. So friends, this much is for now today. I think you understand what is the physical meaning of the vector field integration line for the surface, for the volume. So if you like this video, if you find it helpful, please do share with your friends, subscribe to the channel and join our Telegram channel, and we will upload more tutorial videos for you so that you crack NET, GATE, JEST examinations in physics. Thank you so much.